Welcome to a new episode of Between Two Vulns. We'll be doing the Spotify wrap-up version of AI in this episode.
Just two good Ohio boys, corn-fed from the Midwest.
Yes.
He's definitely not from the country of Italy.
Definitely did not go through Ellis Island.
No.
But yes, we're going to be doing the complete wrap-up of this year. We'll be shouting out some people at the end of the show who did some great stuff on huntr.
Yep.
And but first we're going to talk about AI news. There's a lot of stuff going down. There's a lot of
12 days of shipments for OpenAI.
Yes, correct. Yes.
So,
what is the first day of shipments brought us?
I don't remember.
Oh, okay.
I didn't prepare those notes.
Okay.
You really should stick to the script here because
it's GPT Pro.
So GPT Pro just came out and they raised the prices up to $200 per month for the latest O1 model, which makes sense because it's my understanding that OpenAI is hemorrhaging money because of the cost of running these things.
Yeah.
And it's really cool. So most of the stuff I've read online has said it's kind of a meh increase over O1.
You went ahead and spent the $200.
I did.
Yeah, he actually spent the money.
Or, personal projects too, because here's the thing, and here's why I think this thing is actually pretty crazy, is 4 years ago, it took me about 2 years to write my first model that predicts UFC fights. This was just a thing to help learn machine learning, and it took several years to get it to a semi-profitable state. Then I rewrote it after ChatGPT 3.5 came out, the original one, and it took like 4 months to rewrite from scratch. I have rewritten it from scratch again, and it's taking like a month.
A month, yeah.
And this is the crazy part. It's really good at math. And so what I found is I spent 8 hours on Sunday trying to debug some statistical analysis where I'm using Bayesian smoothing to figure out per stat smooth weight class averages for some stuff. And it gets pretty complicated because the whole database schema has to be incorporated by the AI, the naming conventions of the stats and everything. I spent 8 hours doing that with Claude, and Claude was getting it almost right, and screwing something up here and there because of the complexity of it. It one-shotted, O1 Pro one-shotted the entire thing immediately. So in this specific instance, it sped up my time to goal achievement by like 50x.
That's crazy.
Which is nuts.
Yeah.
And I think that's probably not indicative of its average utility.
Did you give it the strawberry test to see if it can count the amount of R's in strawberry though?
No, I didn't do any of the weird tests that it's done.
That'd be. I would like to see that. We should do that afterwards. I'm kind of curious.
But man,
if we can figure that out.
Its math abilities are really, really good.
Yeah, math is cool though. But can it count R's in the word strawberry?
Right. Can it multiply 1,000 times 1,000? Because a calculator can do that. So therefore, AI is garbage.
Yeah. Call me back when it can count the amount of R's in strawberry. You spent $200.
Here's the thing. If this is an AGI, it's on the cusp. It's better than most humans at most things.
I mean, yeah, but it still can't count the amount of R's in strawberry. So Anthropic released this new thing called Model Context Protocol, which is just a set, it's almost like a way of standardizing the way LLMs interact with tools and services and really anything externally to the LLM. Previously this was being done with random projects there was no standard, it was just whatever works. So the LangChain was a very popular way of using agents to interact with external services. Anthropic came out with this Model Context Protocol, which I think the idea is to create a standard in order to do this. We were talking about this yesterday, but there really isn't anything mind-blowing about it. It's just you could have done this before with other tools.
Yeah.
But the thing that you gain with it for free, quote unquote, is you can just use the Anthropic Claude desktop app with its UI,
right,
to directly interact with other tools and services that you set up with MCP.
Yeah.
So you're gaining a nice, pretty UI, in the artifact stuff. So you can take unstructured data potentially, right, and just have Claude make it into a structured format for you and create graphs using the artifact stuff. So that's kind of cool.
I feel like the main value is it just makes building agents a lot easier.
Yeah.
You don't need these third-party libraries that are constantly changing.
Yeah, and it's less, and it's not really, there's not a lot of dependency hell,
right,
as LangChain is. So it makes it easier. It makes it a standard for sure. I doubt that it'll be adopted by OpenAI, so we'll probably have multiple competing standards. We're back to the whole
Yeah, how many ways can you
how
plug
many
your
ways
phone
can
into
you?
the
Yeah,
wall?
yeah, exactly. So we're back to that whole song and dance. But I mean, it's good to have like the first example
Yeah.
being published by an actual AI company
Like,
on how to do this.
This is probably going to be the start of like an API for everything. Because there's going to be an API for everything, and LLMs are going to be able to query those APIs and do stuff. I've seen there were some arguments on, that of course I'm reading on Reddit and Twitter and stuff, saying how like, well, LLMs and AI can't actually do anything. And it's like, well, they just regurgitate text. And it's like, but they do. You just hook them up to an API, and now they have the actions to launch a nuclear weapon. Like, if there's an API to that nuclear weapon, they can perform that action.
That escalated. You're hooking it up straight. That's the first thing you think of is like nuclear weapons.
I am often on the thought of nuclear holocaust.
Wow.
Yes.
Okay, that's interesting. Okay.
But this is where I see the future going, and especially the future of AI security, is these agent security tasks. How do you make sure your LLM isn't going to deceive you, isn't going to perform a dangerous action? I think there's going to be some product market here for things that inject themselves into the thought process of the agent.
For sure. Yeah.
And that's not here yet.
Yeah, and it's not here yet. We're already, but there's like
we've been noodling.
Yeah, we've been noodling. There's some projects that sort of started doing that, but it'll definitely be a thing for sure that's coming up. That's interesting that you went straight to nuclear weapons though, because I was just thinking, hooking it up to get the weather or something, Just order DoorDash, like normal person.
Order DoorDash, do some research on vacation.
Yeah. It's like, no, you're like nuclear weapons. That's very interesting. Okay, moving on. So the Google Willow quantum chip. This has sort of nothing to do with AI, but at the same time, it sort of does. So there was a huge leap in quantum computing announced yesterday, where like Google managed to basically solve insanely large, complex problem that traditional computers weren't able to solve.
Yeah, it was supposed to take like 7 trillion septillion years.
And
they solved it in 5 minutes.
In 5 minutes with quantum computing, and there was like they managed to get more stable qubits, and they also announced they found a way of basically correcting for errors the more they scale up in qubits, which is a big deal because that's like sort of that was like one of the biggest problems. So that's kind of cool. It's tangentially related to the growth of AI because like if we manage to like get to a point where we're actually using quantum computers, the scale of like LLMs,
the power
just exponentially
grows. And we're seeing
quadruples.
the exponential growth in quantum computing too. I mean, they had 105 qubits. It wasn't that long ago we had 2 qubits.
Yeah. So like in the span of 20 years, like we're getting like 2040, we're going to be seeing like double the amount of qubits probably. And at that point, like it's just going to keep getting better and better. So
yeah, the exponential growth is going. Yeah. Like I see that and room temperature superconductors being like the 2 things that really unlock the, the straight up asymptote.
For sure.
But I thought the most interesting thing about the quantum thing was they basically just kind of threw in at the end of their release that this might be strong evidence that we live in a multiverse, because that's essentially what it's doing, is making calculations across many different potential universes and then coalescing into one answer.
Wow, the Avengers was right. Who knew?
Yeah, it's that is bizarre.
They're gonna start making Quantum 2, Revenge of the Quantum, and they're just gonna keep like creating new multiverses with the okay, never mind. And with that, we'll probably leave it to Ethan
to talk a little more in depth about the model file vulnerability program. It's almost on cue, almost in sync.
Yeah.
Hi hunters, so today we're going to be looking at another example of a model format vulnerability. So last time we looked at pickle deserialization, and today we're going to be looking at kind of the same thing. This time it's in Keras. So TensorFlow is a very, very popular machine learning library that lets you build neural networks. Obviously, they can be very complicated, but today we're going to be looking at a very, very simple example. So you can see here with Keras, you can define your little model, and the way that neural networks work is that there's essentially layers, and they're just like different sections that when you pass in your whatever data that you want to make predictions on, it'll go through each one of those layers. And so you can kind of see here, a super basic example, you'll typically see layers made with these dense layers, right? But today we're going to be looking at a vulnerability in a lambda layer. So a lambda layer is something that you can put a Python lambda function in. And the issue there is that obviously writing a lambda function with Python, it allows you to make arbitrary Python code, right? So in this case, we're defining a lambda function that uses Python's very dangerous eval function. And we're just passing a very simple RCE payload into it. So this, for example, creates a POC file in the host machine's temp folder. And so again, a very simple example. This is a neural network with literally just one layer in it. And what we're doing is once we save this into a model file, whoever loads this model and then runs it, our payload gets executed. So again, remember the data gets passed into one of these layers. So when you actually try to make a prediction on the whatever data you have, it really just runs our Lambda function and then just executes the payload. So you can see here, we'll save the model file. And then, so basically, when we're looking at model format vulnerabilities, you can kind of think about them in two different steps. So what we just did when creating our malicious model file, that's all the attacker does, is it loads a payload into a model file. And what we're looking for in the victim behavior is either loading or, in this case, loading and then running a model file. So, again, this is all the victim here is doing, is loading, installing TensorFlow. You've got the malicious model file, which is basically kind of like a phishing link almost, and it's just loading that in with some, very simple data in this case. And when you run this, you can see our payload gets executed, and we have created the POC folder in the temp folder. Again, a very, very basic example, and kind of similar to the last one that we looked at. And so we kind of wanted to help out with how do you actually find similar vulnerabilities like this. So first off, you want to understand serialization, right? So how are these libraries like TensorFlow or like JobLib, Pickle, whatever, how are they actually storing all of these complex objects that you're creating, the models basically? And then does it support things like what we just done where we define our own custom functions or custom operations within that model, right? That aren't really visible. Looking at the file, you can't really tell what's going on, but we'll come back to that in a sec. So yeah, look for keywords, like custom ops, extensions, callbacks, and you can also do this in the documentation itself, right? So you'd be very surprised. A lot of these libraries will just straight up say like, hey, this function allows you to run arbitrary code, right? So just look for things like arbitrary, custom, dynamic logic, right? So implementing custom logic into these models. Look for security warnings. Again, they'll just straight up tell you. And yeah, any unsafe load options. So like, for example, pickle deserialization is a very common one. And this can go right into the code if it's open source. Look for things like load model, load weights, restore, from file, and then so those are like loading the actual models. You can also look for the functions that run those models and look into that logic as well. So when it comes to actually testing one of these things, so in this example, if we want to insert our own custom logic, it's pretty simple. It's just like you do whatever you need to do for that specific library and do something like, model.add custom operation, right? Add our custom code to it. And then really it's as simple as that. It's just model.save, right? So it's just saving the model. And you can do things with certain types of model files, like viewing it with like a hex dump, right? So in this case, it's an older example. It's in H5 files aren't really used that much anymore. But when you hex dump this example that we've done, this Lambda model H5, you can actually see there's a lot of stuff in here. But if you scroll down, you'll actually see this is what we've created, right? This is our model essentially. And you can actually see the Lambda layers being created in here. And for these Lambda or for these H5 files, you can actually see this whole section right here is base 64 encoded, right? And our payload is actually in there. So that's kind of how you can tell, like, okay, where can I insert stuff? And also, on our end, like, how do we actually look for these kinds of things? How do we scan for these things in our Hugging Face scanner, for example? So, yeah, that's a pretty simple example. And if you go to huntr.com, trying to look for these model format vulnerabilities, yeah, you can basically use the same logic that we've done here, the same one that we've looked at the JobLib deserialization, and yeah, start hunting. So hope that helps. Bye.
It's been a great year for huntr. We found, I want to say, hundreds of vulnerabilities.
Thousands, septillions.
Yeah.
Just like the quantum chip.
Exactly.
In multiple universes all together.
Yes, very theoretical, hypothetical. But
aliens.
The actual 0 days, we've had a lot of these guys and women on the program since the very beginning. And so we just want to give a quick shout out to some of these OGs of the program.
Individual. So we got...
Killing it.
Yeah, killing it.
We've got Patrick Ha.
This is in no
We've got
way,
ZP Brent.
This is in no particular order, by the way. Okay, well, never mind. Just keep going.
And then Kazi.
Okay. Fatmo.
Fatmo,
666.
Hindwin, all of these are some of our top hunters of the year. They were doing some amazing work throughout the year, and actually years, I should say, because they've been around for a long time.
Yeah, ZB Brent, I think, has been around particularly since the inception of Huntr.
Yeah, Hindwin, MN Kazi, and Patrick Ha, actually, I recognize, and RetroReg, I actually recognize all of them.
I recognize all of their names. We've triaged all of their tickets. Yeah. Well, most of them, at least
probably
once.
pissed them off quite a few times.
We apologize.
We're sorry.
In the spirit of the holidays.
We're just going to give you a verbal tip now.
Yes. Yeah, exactly. Exactly. But anyway, really anybody on the leaderboard. If you made it to the Huntr leaderboard, these are just like people that we know, basically, just from interacting with them on Discord and Huntrs. But anyone on the leaderboard, congratulations.
It was a great year. Lots of vulnerabilities found. And with that, I think we'll just cut over to...
Yes. To who? Who are you cutting to?
I don't know.
Dan in the other dimension, in the parallel dimension. Dan number 2.
He's much smarter than I am.
Yeah. And with that, happy holidays, everybody. And enjoy the festivities. English is hard.